Hey guys, welcome back to the channel. In this video, we'll be solving this problem called classes dealing with complex number. So similar to what we have done in the previous question, same thing we'll be doing here as well. For this challenge, you are given two complex numbers and you have to print the result of their addition, subtraction, multiplication, division and modulus. So you have two complex number and you have to perform some arithmetic operations and you have to print it. The real and imaginary precision part should be corrected up to 2 decimal places. Okay, so the values has to be corrected up to 2 decimal places. Now the input format is like this: real and imaginary part of a number separated by a space will be given to you, and the output for two complex numbers C and D, the output has to be in the following sequence on separate lines. So C plus D, C minus D, C into D, C divided by D, mod C, mod D. This is what you have to do at the output. So for the complex number with non-zero real and complex part, the output will be in this fashion: A plus BI. But if you replace the plus symbol plus with minus symbol when B is less than 0, right? So if the value of B is less than 0, then replace this positive sign with negative. Now the complex number having only real part will be represented like this: A plus 0.00i, and if it is having only imaginary part, it will be represented at 0.00 plus bi. Right, so these are the representations you have to take care. And this is an example. C is given 2 1, D is given 5 6, means real part is 2, imaginary part is 1, real part is 5, imaginary part is 6. So C and D is here. You are calculating C plus D, C minus D, C into D, C divided by D, modulus C, modulus D, right? Python is a fully object oriented language, C++, Java, etc., like C++, Java, etc. For reading about more, you can go through here. Now this is what I was talking about in the previous question. So we have seen underscore, init, underscore, right? So similar to that, we had there underscore, sub, underscore, right? So that's can be overloaded with negative this sign. So when you use this dash sign, it will automatically call the underscore sub method. Okay, so this is something called overloading, and I don't want to go into the details. You can go through this page. Here they have mentioned it, so we don't need much of this. You can go through its Python doc. You can see a lot more functions are there, methods are there, sorry. So you can see this LT, LE, these are string types, and then you can see where it is. So here you can see the shifting right left type, then here you can see the add sub. So there are a lot of things you can go through this. I don't want to go into the details. So you have got the touch in the previous example. So let's go through this. What is given to us, you can see here. Similar to what we saw before, definitions are given, the functions are given, you have to complete it, and some main function is given here, main thing which you can't change. So here the value of C is being taken and D is being taken, then they are calling complex, which is the name of the class, and they are passing the value of C. So init function will be called directly with real and imaginary. So here you can directly write self dot real is equal to real. Similarly, self dot imaginary is equal to imaginary, right? So this is what it is. Similarly, add function, subtract, multiplication, to divide, and then mod function, these all things you have to write. Then there is some another function for representation purpose, okay, which is here, these guys. So here you can see, if only imaginary part will be 0, the result will be represented in this fashion. So it is corrected up to 2 decimal places, and then they are adding 0.00i if it is like this. So this is the thing they have represented here. Else if the real part is 0, they will represent it in purely imaginary format. Sorry. Else here you can see, if the real part is 0, inside that they have two condition. If the imaginary part is greater than 0, they are represented in this fashion. If the imaginary part is less than 0, then they are representing in this fashion. You can see there is a negative sign here, there is a positive sign here, absolute value they are taking. Similarly, if the imaginary part is greater than 0, this is how it will be represented, plus sign is there, else minus sign will be there if it is less than 0, and they are finally returning the result. So they are the representation part. This is already being done for you. You just have to write these functions, right? Add, subtract, multiply, divide, mod. And here you can see that the how they are calling it. So by plus sign you are calling add function, then by minus sign sub function, star sign it is calling the multiply, then divide, then mod, you can see here, and they are printed in each line, right? So all these is being taken care. The str will convert into string. So all these is being taken care. You just have to write these functions, add and all. So let's write it. So you have two number. So if you are performing addition, real will get added to real, right? And then imaginary will get added to imaginary. So let's return self dot real plus adding vr, right? So number dot real, right? This will give you the real part. Similarly, same thing I'll do with imaginary part. So here I'll convert this into imaginary. Similarly here as well I'll convert into imaginary, right? So this will give you xy coordinates, right? But the problem is again it is in tuple form. So we'll give it to the class complex, right? Complex. This is how it will look. Let's see. Let me pass and then pass. Similarly here also I'll do pass. Similarly here also pass, right? Because you can't keep it empty. So it should not provide, yeah, so it is working, add is there, right? If I won't put complex, what will be the problem? You can see it will show tuple thing, that is an tuple. So see, this is an tuple now, but the representation has to be in this fashion. So just do the complex and it will take care of its own. The representation is being taken care by this guy. str is called here, right? This you can see. Not here. This is converting the string, these guys into string form. This will be taken care by when you will call the complex. Okay, when you will pass it and it will see that imaginary part is 0 or not, whether real part is 0 or not, and it will mold the function automatically. Okay, and it will return here, sorry, here x plus y, and then this will convert into string and it will print it. So that's how it is working. The same thing I'll do with sub. So let's copy this guy, Control C, Control V, but this time we'll subtract it. Real will get subtracted to real, imaginary will get subtracted to imaginary, right? Self dot real minus number dot real, self dot imaginary minus number dot imaginary. So this will give the subtraction. So here you can see we are getting the subtraction, right? Same as it is 7 7 minus minus, right? So now we'll do the multiplication. So multiplication part, if so let me copy it. So multiplication part is there are four terms, right? Real with multiply with real, real with imaginary, imaginary with real, and imaginary with imaginary, right? A B. So if you know the multiplication, so there will be four terms, right? So real with real plus imaginary with imaginary, right? So here plus will be there, imaginary with imaginary. So this will give you a real part, right? This will give you real part. Similarly, the next guy is real with imaginary and imaginary with real. So here you have self real guy will multiply with imaginary number. So imaginary part and the reverse of it, plus self dot imaginary will be multiplied to number dot real. I think it was correct. Okay, so a plus b, c plus di will multiply like this, right? C plus multiplication of two vectors, not vectors, complex numbers. So here you can see this is what I have done, right? So the sign will be taken care by itself. So images, so where can we see? So this is the thing I have done. A plus bi plus c plus di, ac minus bd plus I into ad plus bc. And so here also you can see real will be get multiplied with real and imaginary will be multiplied with imaginary. So this actually this minus sign is removed by the I square term. Imaginary multiply with imaginary will give you I square, so minus sign will be there, so it will become plus. Okay, so that is how the multiplication is being done. Oops, I think I did a mistake. I think this minus sign has to be there, because a into c, b into d, and I square will give you minus here. Okay, yeah, minus sign should come here, right? So ad ac minus bd, then plus is same, plus is clear here, so this has to be minus. Let's do it. 4 plus 79, 4 plus 79, yeah, we are getting it. Now let's do the divide, but first let me do the mod thing. So mod thing will take less time, no? So let me paste it, let me write it. Okay, so I think I've done it. So here you can see modulus first I have calculated. So whatever the self real will be, square of it plus self imaginary square of it, and then under root I have taken here. Okay, so that is how. And complex I have writing, although it is a scalar number, but still I am passing it to complex so that it will represent in this fashion. Okay, okay, missing one required positional argument, imaginary complex. Okay, imaginary. Okay, so it will be a real thing, no? It will be a real value, so you have to pass some value in imaginary. So we'll provide what, 0.00, right? So let me provide 0 here, and it will take care of itself. So imaginary part we have not provided, and that's why it is showing error. It needs real and imaginary part. The imaginary part is not there, that's why I'm giving 0. So now it is taken care. See, this guy as well as this guy. So whenever whatever you are passing and calling with, so x is being transferred here, and here y is transferred, so that's why it is different. So you can see this is calculated depending upon what you are calling with, x or y. Now you have divide only remaining, so which is a bigger one. So because rationalization and all I am considering, so how you go do it, c divided by d is equal to c divided by d into d divided by d, right? Means like rationalization if you know, and then solving it will give you the division. So the whole expression I will write, I'm planning. So first I'll get numerator 1, right? So numerator 1 I am getting self real, which is here. Let me write it and then I'll explain. Okay, so yeah, I think I finished. So you can see by rationalizing and separating real and imaginary part, this is what you'll get. So numerator part, this numerator 1 is real part, numerator 1, which is calculated by real part multiplied plus imaginary part multiplied, plus there is a conjugation you can see because of rationalization. Then numerator 2 will give you the imaginary part, likewise imaginary into real minus real into imaginary conjugate. Okay, so that conjugate will take care of this minus sign if it has to be. So that's how you can try different things, means like real into imaginary, imaginary into real, so you'll see the difference. Okay, so let me do plus only so that you will see. Then what I have calculated, denominator is x square plus y square, right? So that's what I have done for number part, and then I have calculated real part, numerator 1 divided by denominator and numerator 2 divided by denominator. So the complex, because it has to be represented in required fashion. So you can see the value 0.26 is coming, but 0.28 is not coming. Let me do minus, and then it will come. So you do the calculation. So that's what I've done. I did it via pen and paper, and then I thought of this logic. So this is the only good one here, and plus the rest is all straightforward types. So this is what we had to write. Sample test cases passed, all the test cases are passed, and you are done. So we have solved the classes problems. So hopefully it gave you a feel, a different type of feel. It looks big, the code looks really big, but the logic is simple. You just be patient and start doing it. So that's what I'll suggest. So let's move on to the next problem now.